Engineering. I'm Alan. In last week's video we started to make a handle for the headstock on the lathe. We started with this steering wheel, removing the rubber from the back to get a flat face so that this would then go up against the back of the headstock on the lathe. This week we start to make the mandrel that goes through the wheel. That locates into the back of the wheel and then gives us an expanding part this end that grips the bore in the headstock. So as you tighten a nut up on the end, this opens out, grips the bore. You can turn the headstock by using the steering wheel to control the position of the chuck. So let's go to the workshop and see how we do it. So today we're making the body of the headstock handle, and I'm making it out of this 30mm diameter piece of steel. I've put my 4-jaw chuck on because the 30mm diameter will go further into the chuck than on my 3-jaw. So on my 3-jaw I'd need to hold the end just in the jaw here where it goes back into the chuck about 2 inches. What I want to do is rough this out, put centres in it, so I can do the final finishing cuts between centres, which means I can remove it from the lathe, try the fit, and then put it back in the lathe, take a bit more off or polish it. So the first thing I want to do on here is get this running true, and I've already set the jaws up. So this is running out a thou in the middle, but obviously each end, depends where you go, it will run out more depending on how your chuck is. Yeah, it's running out 3 thou, 4 thou. So I've taken the middle part to balance it out. With this revolving centering, I have a problem. When the tool post is the normal way, tool on this side like that, I can't get the tool tip further enough back without angling the tool post, which then makes it awkward when I come down here. So what I've done is just put the tool on the other side so that I can now come into the face, and I only need to go along 70mm, which is about there, machine this diameter. This diameter is 29mm and this diameter is 22mm, which are just over the bore size of each component that I want it to fit. So I've just roughed this out. Now before I part this off here, I want to drill a hole in the end and form the cone on the inside to fit the cone nut that we already made. This length is 70mm and this length is 70, so with my 6mm drill I need to go in at least halfway. Now because I'm going deeper than the flute on the drill, as soon as this part enters a hole it stops the swarf coming out and jams up the drill. So what I'm doing is pulling the drill out every now and again, cleaning out the swarf, and then continuing to drill. So if we look at the nut that we made, that's a tapered nut which has to go in a hole in the end here. So the next job I want to do is drill a hole 12 mil and go down 30 mil. So what I'm doing at the moment is just boring this out until this taper nut that we made will just start to go in the bore. Now I've bored that out just so this goes in to there. So now what I need to do is bore this out to the correct taper. I've set my compound slide to the 1.5 degrees the other way, so I can now use my boring bar to bore that hole to a 1.5 degree taper. Now an easy way to put your tapered nut in is just fit it to a 6mm bolt. So now you can put that in there and it just goes in and stops about 22mm into the bore. So I can pull this nut in that far before it hits the bottom of the bore. And I need the nut to go in to the bore, this end, because I want to put a small pin in there that will locate the nut and stop it turning. Because I've drilled and bored this end of the mandrel, I've now lost my centre. So the last thing to do is just machine a centre, 60-degree centre in the end. So when I part this off, I still have a centre in this end, turn it round in the chuck, put a centre in the other end, and I can machine it between centres to get the final finish. Now if you're not sure whether you've got the compound slide set right, what you can do is take your centre, just press the point up against the edge of the compound slide, and the Morse taper or the end of the centre should be parallel with your tailstock. That will give you an idea whether you've got the angle set properly on your compound slide. There's the chamfer on the very end, just enough to locate a centre in. I tried this using my normal tool that I use and it chipped the corner off, and I had a lot of vibration with that. So I've gone to a 3mm insert, and this seems to be cutting it okay. I'm not going to go all the way through because this is quite a big piece of metal to have drop onto your lathe bed. So what I'm going to do is part it down to about 1/4 of an inch and then just saw the last bit off so I can control the metal. 6mm hole right the way through. So in this end we've got a centre hole and a 6mm hole all the way through. That's just been roughed out. This end we've got the taper for the nut. The nut goes in just below the surface. I fitted my tool post drill with the centre drill in. I've moved from the edge of the component down 30mm, and I want to drill 4 holes around the outside of this diameter. Now the easiest way to do that is use the chuck, and then by putting a fixed bar onto the bed, turn it round until the chuck jaw hits it, and now you've set that chuck, and all I do is drill a hole, then turn it round to the next jaw, drill the next hole. I'm putting a slight countersink on the hole, so now I'll turn it round to the next hole. I've put the part between centres. I've put the driving plate on, driving dog, a centre in this end and a revolving centre in this end. Now I don't need to put any oil or any grease on the centres. This one's revolving, so it's already got bearings and grease. This one turns with the part, so there should be no wear in the bore of this. Because I machined the centres in the chuck afterwards, we'll just see what the run out of this is. That's about half a thou. Each division's a tenth. That's about half a thou there. And this one looks about the same. So the next job is to machine this down to get it running true, which is just take a light skim, and then start to machine this end down so it fits the boss on the steering wheel. Okay, this is the setup. I've put my tool on the right hand side of the tool post. Normally you'd have it on this side. By the time I get down to the end of this diameter, the tool post is right over here. I've also checked that this driving dog is clear of hitting the tool post, so that's clear. I don't need to go any further than the end of this. So I'm machining this diameter down to get it to run true. I have 1mm left on here, so I'll take a light skim off. And this is the reason why I put the centres in, because I can take this out and check it for size on the part, and it still doesn't go in, so that's like a press fit in there. done is just gone down about a thou on the very end, so that'll give me a lead. Now that's a surprise. This bush in the middle of the steering wheel is ground and hardened. Now this way it just starts to go in. You see, it's just going in. If I turn it over on this side, it goes right in. So there's a tapered bore in the middle, and that's a good fit in there. So all I need to do now is finish off the face. So that gives me a flat face. I want to put chamfer on the outside. So the next thing I need to do is drill and tap the end of this bore. I've set up a tap. This is a 12mm tap, and I want to go in about 30mm deep. So that's a 12mm thread in the end. So all I need to do to finish this off now is make the slits to join the end. This is the steering wheel. This is the mandrel we've made so far. Tapered bore. We've put 4 holes around the outside, and on this end we've reduced the diameter so it fits in the wheel. You can see that won't go in this side. If I turn it over and put it in there, it fits in there right up to the face. And on this end we've drilled and tapped a 12mm hole. So the next thing to do is fit this to the wheel so it won't rotate, and finish off the slots so this part will expand when I pull the tapered nut in. Well, that's it for today. I hope that was useful. Hope it was interesting for you, and we'll see you next time on Enots Engineering.